In this demonstration video, we will showcase the KnowledgeStore, a scalable, fault-tolerant and semantic web-grounded framework to jointly store, manage, retrieve and query both unstructured and structured content. In particular, the video will show how human users can easily interact with the KnowledgeStore through the KnowledgeStore user interface. The dataset used for this demonstration was built in the context of the NewsReader European project, by processing 1.3 million news documents about the global automotive industry, covering a 10-year period from 2003 to 2013. The news articles were made available for project purposes by LexisNexis. Besides the source news, the KnowledgeStore contains 1.3 million NLP annotation files in NAV format, obtained by processing the news with the NewsReader NLP pipeline. 205 million mentions of various types were detected, out of which 439 million RDF triples were distilled. In addition, the KnowledgeStore contains 96 million triples coming from a selected subset of DBpedia 2014, summing up to a total of 535 million triples about events, persons, organizations, locations, and so on. We recall that the KnowledgeStore adopts state-of-the-art technologies such as Zookeeper, Hadoop, HBase, Virtuoso, and the version showcased in this video was hosted on a cluster of 5 average-spec machines. This is the entry point of the KnowledgeStore user interface. The KnowledgeStore UI is a basic web-based application whose main purpose is to enable users to inspect and navigate the KnowledgeStore content without having to develop an application accessing the KnowledgeStore API. 2 core operations are offered: the Sparkle query operation, with which arbitrary Sparkle queries can be run against the KnowledgeStore, obtaining the results directly in the browser or as a downloadable file, and the lookup operation, which, given the URI of an object like a resource, mention and entity, retrieves all the KnowledgeStore content about that object. We will start our demonstration by accessing the KnowledgeStore Sparkle endpoint. Arbitrary Sparkle queries can be fired to the KnowledgeStore by typing them into the text box. On the bottom right, some example of queries can be recalled. Let's pick the last one. This query searches for all events in the KnowledgeStore of type joining an organization, such as the hiring of an employee, where Kia Motors company was involved. Besides the URI of the event, the query asks for their label and date. The users can decide to obtain the results directly in the UI by clicking Display Results, or to download them as a file in one of the many supported formats, including the recently standardized JSON LD. A timeout value can also be set together with the query. If the query execution takes longer than it, the processing is terminated and the partial results computed so far are returned. So let's see the results for the selected query. We have 3 events. Let's pick one of them, for instance the last one. We are now performing an entity lookup using the lookup operation offered by the UI. Here is the output obtained. In the top box, you get all the resources mentioning that entity, together with the corresponding date and title. The last column reports the number of times that entity is mentioned in the resource. In our case, the event is mentioned twice in one news article from 2006. In the second box, all triples about the entity passed to the lookup operation are displayed. For instance, we can see that the selected event has certain types, according to some ontology used in the project, such as FrameNet hiring or ASO joining an organization. Among other triples, we see that 2 participants or actors, according to the simple event model terminology, were involved in the event: Peter Schreier and Kia Motors, the former as an employee, while the latter as employer. Note that both actors correspond to URI in DBpedia, and we can access DBpedia to see additional triples about these entities using the dereferencing functionality. Alternatively, we can perform a lookup on that URI to access all the knowledge store content about that particular entity, obtaining all the resources where the entity is mentioned and its corresponding triples. Getting back to our starting example, we can see now how we can access the actual mentions of an entity via the graph denoted by assertions. In this case, we have two such assertions, telling us that the event is mentioned twice in some news. Let's pick one of the two mentions and perform a lookup on its URI. Mentions bridge resources and entities, and this is reminded in the UI with the three boxes returned when performing a lookup on a mention URI. In the first box, we can see a resource excerpt of the portion of text where the mention occurs, with the characters corresponding to the mention highlighted. In the second box, we can access the attributes stored in the knowledge store for that mention. For example, its URI, the URI of the resource containing the mention, reference to external resources such as ASO, FrameNet, ProBank, VerbNet, and WordNet. We also have information about the factuality value of the mention and its exact position in the text, stored according to the NIF vocabulary. Finally, we can see that this is a mention of an event by looking at the RDF type assertions. In the third and final box, we can see an extract of the triples of the entity corresponding to the mention. You can recognize the triples of the event we previously accessed. By clicking on the resource link on top of the page, we can perform a lookup for the resource containing the mention, so we can see the mention in the context of the news where it was detected. As you can see, several pieces of text are highlighted in different colors corresponding to different mentions detected in the text. Over in them, you see that we have mention of events, organizations, persons, locations, and other entities. By clicking on them, we can directly access all the attributes of each mention. Mentions in a resource can also be accessed through the link on the top right corner of the page, or the users can directly access an entity mentioned in the text. Besides having the chance to download the source news in various formats, the UI allows to access the metadata attached to resources. For instance, its URI, metadata of the physical file containing the resource, the link to the NAF annotated version of the resource, the document creation time, its language, the URL of the original source file, its title, and its type. By clicking on the target URI of the annotated with attribute, we can access the NAF annotated version of the resource, and we can browse its metadata, such as the information on the annotation layers contained in the NAF file. The navigation of the knowledge store content can also start with the lookup operation in the UI. One can start with the URI of any object in the knowledge store, like a resource, then access its mention, like this one about Lancia Delta, and then the corresponding entity in the entity layer, to see all resources mentioning that entity, as well as all its triples, including the link to all its mentions. Documentation, software, and additional materials can be accessed from the Knowledge Store website at knowledgestore.fbk.eu. From the website, the user can access the Knowledge Store JavaDoc API documentation, get the data model ontologies, download the precompiled binaries of all the components of the knowledge store, also accessible on Maven Central, and obtain the background knowledge datasets used in the knowledge store installations for NewsReader. Access to knowledge store related publication is also provided. This demonstration video, as well as several running installations, are also accessible through the website. To conclude, we recall that the Knowledge Store provides two dedicated HTTP REST endpoints to programmatically access its content: the CRUD endpoint and the Sparkle endpoint. A documentation of the available methods is provided on the website.